Today I'm going to be going over the two of the variants for problem 5.1. Uh, we need to go over the Dutch flag partition, but with multiple keys. That's right. You're given an array of n objects with keys that take one of four values. Okay, one of three values. Reorder the array so that all objects with the same key appear together. All right. So notice in the Dutch flag partition how we have different sections. We have our bottom section, we have our middle section, unclassified section, and your top section, right? So the idea is uh, that we divided it into multiple sections. And if I haven't gone over the solution with you guys, we can do that real quick. Um, so you have a smaller, an equals, and a larger. The equals is basically what is going to track your indeterminate, your unknowns. So if I'm over here, sure, I know what one is, but the rest of them, I don't really know what they are. So we have like a two-pointer sort of approach where I use the first element, uh, and I'm setting that as start, as the smaller part and the equal part, and the equal pointer, and the large part is over here, which means that it's completely empty, and the small part is at least this. So to start with, we want to sort of initialize the, I guess, the array indices, right? You have your smaller equals and your larger. Um, I I feel like I'm not doing a great job of explaining this. So you sort of, so the original solution that we looked at was this, right? We have a selection sort and a reversed selection sort that ignores the middle part. But this approach is sort of taking a bunch of unknowns, right? We're taking an array of unknowns, and we're trying to break them into knowns. So if it's smaller, I want to break it into a. Uh, if it's smaller, I want to put it here, and if it's bigger, then my pivot would pivot being 3, then I want to move it over here. So I'll swap a question mark out for a 5, and so on and so forth. So that's basically our approach. Um, how we do that is two-pointer method. Smaller equals and setting larger as this. So setting it outside of our array gives us extra flexibility because we have this top section. We have it from larger to the end. Um, so what do we do? You can sort of think of it as two parts. You have a known, an unknown, and a known part. The unknown part I didn't count because it shrinks. It slowly gets smaller, 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 and then all we have is two knowns, right? We have our elements that are less than the pivot, elements that are equal to the pivot, and elements that are greater than the pivot. So that's how we're going to do it. So similar to, okay, yeah, so this is kind of the weird part, right? So what is this condition? Equals less than larger. So you never want your larger array to get all the way over because it's never going to be all the way over, right? And so why isn't it less than smaller? Um, Smaller essentially will stop once it gets to the smallest term. Let's say it's 2. But equals will go further, right? It could be two twos. And then small would have stopped over here, whereas equals would have been over here. And then you never want these two to cross. So that's why you have equals is less than larger. So your boundary condition, you never want it to sort of cross um, your reverse implementation of this pointer. So that's the explanation for why equals is less than larger. I'm not super like it's not super intuitive, but I think it sort of makes sense the more you think about it. Um, if A equals less than pivot. So that's basically for the smaller part. If it's less than pivot, mm, reverse everything. I mean, swap everything. So the small and equals. So that would just be 1 and 1 here. And then move everything up, right? So small and equals move up. Else, if it's equal to the pivot, just move equals up. So equals now moves up. Right. And now we have 4. So larger comes down. It's now within our realm of use. And A equals larger. And so these elements swap, right? So 4, is 4 and 2 really swap? No, equals would have gotten past here. So I missed that last step, the iterable. So equals would have come here and it would have jumped here. And then for the second two, equals would have already been on top of last. Or so you wouldn't have equals less than larger. So this would have stayed here and then larger would have kicked in. And that's it. There you go. I mean, that's what it would have looked like. So this is the basic implementation of that. Hopefully that was clear. Sorry if I rushed through that. I just really wanted to sort of show you guys how to do this part and show you the similarities. So the variant is Dutch flag 4 parts, right? So you have 2 keys. Key 3 is not being used because, like just like how you have here, it's larger. The larger part is sort of held with in the else condition. So before we look at that, here we notice that there are ranges, whereas here you have solid keys. If we read the problem, it's given assuming that keys take one of 3 values, so they're equal to something. So rather than ranges, you have them being equal to things, and your selector, your equals array is basically an unknown, and the larger iterator, I mean the end sort of known segment is your key 3. And so you have the same idea, while equals is less than larger. Um, since we're not looking at ranges, we're not looking for an if less than pivot, if equal to pivot, if greater than pivot. We're just looking for if equals key 1, if equals key 2, and else do the same thing. So this approach is exactly the same as this, and that's the only difference is the conditionals are different. So I think that's probably one of the most beautiful parts about programming. It's you just have differences in these tiny steps that can change your approach, and you don't really need to completely reinvent the wheel. You just have to find out what those minute steps are, and then find out if an existing solution could sort of solve your problem. And in this case, it does beautifully. Right? All we had to do is change the conditionals. So that's that. I'm gonna write the Dutch flag 5 parts for myself. But yeah, I'm just working through the sort of schedule that's over here. It's on table 1.2. It's the programs for column 1, column 0, and column 1, and I'll probably be doing column 2, I think as well. Is that 20.15? So that's over here. So it looks like I have only column 0 and column 1 scheduled for this week. But yeah, I mean, that's that. Hope you guys have a nice day.